All right, this is our Algebra Review Day 2. We're going to start with recalling the information we know about imaginary numbers. First off, we have the number I, which is equivalent to the square root of -1. Therefore, I squared. If you square that, you get -1. So what we need to know from this is that if you see a square root of -1 in an answer, we don't want that. We want I instead. And if you see an I squared in an answer, we don't want that. We'll replace it with a -1. All right, so this first section here is solving quadratic equations. Notice the directions say solve for all solutions. That's real and imaginary. So how I tell students to approach this is that they want to try to solve by square rooting. In order to solve by square rooting, they should not be able to see an x squared and an x. If you see both an x squared and an x, that means you cannot solve by square rooting. So if you look at these 5 equations right here, on D and E, I see an x squared and an x, so therefore I cannot solve by square rooting, but on the first 3, I can. So let's go ahead and solve those by square rooting. So we want to isolate our x squared, so we're going to subtract 3 from both sides. We have x squared is equal to -9, and now we are going to solve by square rooting. We're going to get rid of that square by square rooting. So I'll do square root both sides. And then I have to account for both the positive and negative solution that work when you plug it back in and square it. So we're going to do plus or minus. We have x equals plus or minus. And now I need to know what the square root of -9 is. If it was the square root of +9, I know that is 3, but it's not +9. So what I want to do is I want to break this up. -9 is the same thing as 9 times -1. And now if I change those to radicals, root 9 times root -1, I could simplify each of those. This is 3, this is I. So that's 3I. The way I like to look at it is that if I see a negative underneath a radical, I know I is in my answer. So you have 2 solutions, positive 3I and negative 3I. All right, likewise, this one's pretty similar. To get x squared by itself, I'm going to add 8 to both sides. Square root to solve. Don't forget to account for both that positive and negative solution. That'll work when you plug it back in. And now I need to do the square root of 8. Unlike the square root of 9, root 8 is not a perfect square. It also doesn't have a negative in it, so I is not in my answer. So what I want to do is I want to simplify root 8. To simplify a radical, you're looking for any perfect squares that are factors of 8. So let's list some perfect squares here. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, so on and so forth. So root 8, I'm looking for a factor of 8. 8 falls in line right here, so I know that 9, 16, and 25 are out. So the only way I can look is this way, and I want to know if 4 is a factor of 8, which it is. That's 4 times 2, and remember, it's radical 4, radical 2. Simplify your perfect square, so that's 2, so this is 2 root 2, so plus or minus 2 root 2. All right, moving on to the next one right here. I want to solve by square rooting, but once again, I have to get rid of this plus 3, so I'm going to start by subtracting 3 from both sides. We have x minus 1 quantity squared is equal to 4, and now I can get rid of that square by square rooting. Don't forget your plus or minus. X minus 1 is equal to plus or minus. We do know the square root of 4. It is 2. Add 1 to both sides to get x by itself. And we have x equals 1 plus or minus 2. We want to write this first, this second. Now, this is simplifiable. We can actually go further in this. We can do 1 plus 2, which is 3. And we can also do 1 minus 2, which is -1. So you have 2 solutions right here, x equals 3 and x equals -1. All right, now let's move on to these 2. When I look at these, I see an x squared and an x, so I know I cannot solve by square rooting. So we want to try our next easiest way to solve a quadratic, which is by factoring. So, excuse me, in order to factor, I need to get my quadratic equal to 0 first. Okay, it has to be equal to 0 in order to factor it. So the first thing I'm going to do is get it equal to 0. I'm going to add 20 to both sides. I have x squared plus 9x plus 20 equals 0. All right, so now we have 3 variables that not 3 variables, but we have 3 numbers that we are going to assign variables. The coefficient in front of x squared is a, the coefficient in front of x is b, and the constant is c. So a is 1, b is 9, c is 20. So in order to factor this, we are looking for 2 numbers that multiply to give us a times c. So 1 times 20 is 20. and add to give us b, which is 9. So two numbers that multiply to give us 20 and add to give us 9 are 5 and 4. And then this next step is you're going to take the lead coefficient, or the a value, which is 1, and divide each of those numbers by 1. Now, if this is a number other than 1, it's always, one of them is always going to be simplifiable. So you would have to simplify it, but dividing by 1, we're not going to simplify it. So now you just have to write your factors. Your first factor, it doesn't matter which one's your first one, but the first factor that I'm going to write down, what some people call this bottoms up or upside down, because you're working from the bottom to the top. This is your x value, so that's a 1x, and then plus 5. So that's an x plus 5. We don't write the 1 in front of the x. This right here is an x, so this is x plus 4, and then equals 0. So if I were to multiply these two binomials out, I would get this. All right, now we still have to solve it because the directions are solve and it's an equation. So we're going to use the zero product property. That means we're going to set each of these factors, this factor and this factor, equal to 0 and solve. Subtract 5 from both sides, you get x equals -5. Subtract 4 from both sides, you get x equals -4. And those are your two solutions. All right, let's move on to this one. I see an x squared and an x, so I cannot solve it by square rooting, so I'm going to try to factor it. All right, so I'm going to do a times c. That's 1 times -1, which is -1. Excuse me. B is 6. I'm looking for two numbers that multiply to give me -1 and add to give me 6. Well, can't do that, so I cannot solve it by factoring. So what we have to move on is to our third option, which is the quadratic formula. Now, all of these equations can be solved by using the quadratic formula, but it's the most amount of work, so you don't want to use it unless you have to. So we need our a, b, and c value. Once again, a is 1, b is 6, c is -1. And then here's the quadratic formula. It's x equals the opposite of b plus or minus the square root of b squared minus 4 times the a value times the c value all over 2 times the a value. Okay? All right, so let's go ahead and use the quadratic formula. Also, please notice I put parentheses around b, a, c, and a, and that's because there is squaring or multiplication involved, and we want to make sure we don't get our negatives lost or think it's accidentally subtraction. All right, so we have the opposite of the b value, which is a -6, plus or minus the square root of the b value squared, so 6 squared, minus 4 times a, which is 1, c, which is -1, all over 2 times the a value, which is 1. Now we're going to clean this up. So we're going to clean this up by cleaning up this number, and this number. All right, so we have x equals -6 plus or minus the square root of, we're going to do 6 squared first, which is 36. And then we're going to multiply these three numbers. These three numbers, when you multiply them, it's either going to be a positive number or a negative number. This number will always be positive. And if it's a positive number, you put plus. If it's a negative number, you put minus, right? So -4 times 1 times -4 is +4. So we're going to put a +4. If it looked like this instead, it's going to be a -4, and we'd put a -4 here, right? But it's a +4. All over 2. All right, now we're going to clean it up by adding these two numbers together. And this is all no calculator. Otherwise, I would just pop the whole radicand in the calculator. -6 plus or minus the square root of 40 all over 2. Still going to simplify. We have to see if this radical is simplifiable, which it is. So let's go back to our list of perfect squares. I'm going to take that and drag that down here. Okay, so perfect squares. Mine is 40. So I need to go up to at least 40 here. So I have 25, 36, and 49 is too far, so definitely not 49. 36 is not a factor of 40. 25 is not, 16 is not, 9 is not, but 4 is. So 4 goes in there, root 4 goes in there, root 10 times, root 4 is 2. So that's going to simplify to 2 root 10. So now I have x equals -6 plus or minus 2 root 10 all over 2. Now you have to check to see if this is simplifiable. Sometimes this will be your final answer, sometimes it's not. So if you look at these three numbers, you have to see if they're all divisible by the same number. If they are, it's simplifiable. If they're not, then it's not. So if this was a 3, then I couldn't simplify this and I'd be done. okay? But it's a 2. They're all simplifiable by 2. 2 goes in here once, 2 goes in here once, 2 goes in here negative 3 times. So we have x equals negative 3 plus or minus. We have 1 root 10. This is like having 1x. Like you don't need the 1, so we're just going to write root 10. And then all over 1, which we don't ever write all over 1 as a final answer. So this is our final answer. If you have this 1 right here, I'm okay with it, but please don't put the all over 1 because it's not simplified. Okay, let's move on to the next section, which is imaginary number properties. So we have 3 different types of problems right here. We have a subtraction problem, a problem where you square the imaginary number, and then we have where you multiply. So we're going to start with the subtraction one. The first thing I say is I really wish this was addition, because if it was addition, I would just combine like terms. So I can change subtraction to addition. Yes, I said that right. I can change subtraction to addition. So if I didn't know what minus 5 was, I could add negative 5. It's the same thing. So what we're going to do is we're going to add the opposite. To add the opposite, we're basically distributing a negative. So I'm going to change it to plus, and then take the opposite of this and the opposite of this. Now it's addition, and I can combine like terms. When you're combining like terms, you're going to combine the real parts. 6 and negative 2 is 4. And then you're going to combine the imaginary parts. 3i and 5i is 8i. So it's 4 plus 8i. You always want to write your imaginary numbers in standard form, which is a plus bi form. That's the real part first and then the imaginary part second. All right, we're actually going to do C next, and you'll see why once we get moving on B. So this is multiplication because it's 2 binomials written next to each other. So we're going to multiply them. So we're going to use distribution. So we're going to start by distributing this 4 to this term and then this term. It's also called foiling because you're going to multiply the first 2 terms, the outer 2 terms. All right, so 4 times 4 is 16. 4 times 3i is 12i. Then you're going to distribute this negative 3. This is called inner and last. So negative 3i times 4 is negative 12i. Negative 3i times positive 3i is negative 9i squared. All right, if you combine like terms right now, I see a 16 but no other constant. I see a 12i and a negative 12i. Those both have I in it. I can combine those. If I can combine these two, they cancel each other out. And it looks like these two I can't combine, but all of a sudden I notice I have an I squared. Remember from the recall at top, I squared is the same thing as negative 1. So I can replace that with the negative 1. So now I have negative 9 times negative 1, which is positive 9. So these are like terms, 16 and a 9, and I get 25. All right, let's go back to this one. Okay, so if I just said to you, I'm going to change a problem. I'm not changing, I'm just going to give you a sideline problem. I said 5 squared. Most people are like 25, okay? But if I say, tell me 5 squared is a shortcut to writing what? It's 5 times 5, right? It's this number times itself. So it's the same idea here. When I square something, it's this number times itself. So we're going to do 2 plus I times 2 plus I. Oops, that plus looks like a T. And now it's just like part C that we did. So we need to multiply these. We're going to distribute this 2. 2 times 2 is 4. 2 times I is 2I. Distribute this positive I. I times 2 is 2I. I times I is I squared. All right. So now I see that I squared right away. So I'm going to say I squared is the same thing as negative 1. Coefficient is 1, so 1 times negative 1 is just a negative 1. Combine like terms. 4 and negative 1 is 3. 2i and 2i is 4i. And remember, you want the real part first, which is the 3, the imaginary part second, which is the 4i. All right, now let's move on to our next section, which is our last section, which is graphing quadratics. So we're going to do 2 forms of quadratics, which is standard form and vertex form. So let's recall what standard form looks like. Standard form is in the form y equals, or it could be f of x equals, or g of x, or p of x. ax squared plus bx plus c. So that's what we were trying to get our quadratics to look like. Ax squared plus bx plus c. All right, but these are y equals. All right, so when graphing, we're going to start by finding the axis of symmetry and the x value of the vertex. To find the x value of the vertex, it's x equals the opposite of b over 2 times a. So this is just an important formula to know with that. I don't want to bubble it because this is actually standard form. Okay, next is vertex form. So vertex form is y equals a times x minus h quantity squared plus k. The reason this is called vertex form is because you can literally see the vertex by looking at the equation. The vertex is the h value, comma, the k value. Notice the h value has a minus in front of it in this, so you're always going to take the opposite of it. The k value has a plus in it, so you're going to take it for what it is. Okay, let's go ahead and graph these two quadratics. So we're going to start with this first one here. This is in standard form. A is negative 1, B is negative 4, and C is negative 3. So we are going to start by finding the vertex. To find the x value of the vertex, we are going to use x equals, I'm going to move it over here, x equals the opposite of the b value, so opposite of negative 4 is positive 4, over 2 times the a value, which is negative 1. Simplify that to negative 2, and that's the x value of your vertex. Now to find the y value, we're going to plug in negative 2 here and here. So I'm going to do it in a different color so it's colorized here, or matching up. F of negative 2, I'm plugging in negative 2, so I have this negative, and then I'm plugging in negative 2 for x and squaring it, minus 4 times negative 2 minus 3. All right, so let's see what this is. We're going to make sure you're doing orders of operations. Negative 2 squared is 4. Then I have to take the opposite of that, so that's negative 4. Negative 4 times negative 2 is positive 8, and then minus 3. So that is 1. Okay, we can go ahead and graph that. Negative 2, 1, right there. Okay. All right, we need our y-intercept. Our y-intercept is somewhere on the y-axis, so it's always 0 comma something. So we're going to plug in 0 for x and see what we get for y. So if I plug in 0, we're going to find f of 0. Plug in 0 for x and see what we get for y. If we plug in 0 here and here, we just get this. It's the c value, so negative 3. So we're going to graph 0, negative 3, which is right here. Okay, now remember, quadratics or parabolas are symmetric. So the pink point is your vertex, and there's an axis of symmetry right here. Okay. We know that there is a point equidistant on the other side of the axis of symmetry. So if you look, this is 2 away. So there's going to be another point 2 away right here. Okay, I'm going to clean this up because it don't look good. I'm going to get rid of that axis of symmetry. I'm just going to visualize it. If you want to keep your axis of symmetry, you can. It just has to be dashed. So there should be another point at negative 4, negative 3. Lastly, your x-intercepts, they're always something comma 0. So what we're going to do is we got to set y equal to 0 or f of x equal to 0. So I'm going to replace this with a 0. 0 equals negative x squared minus 4x minus 3. I'm just copying this right here. All right, so now we need to solve this. Now remember, this is a quadratic. So this goes back to solving our quadratics. We cannot solve it by square rooting because there's an x squared and an x, so we're going to try factoring. Before I look for a times c, I do notice that my lead coefficient is negative, and I personally hate that. So I'm going to start by factoring that negative out. So I have 0 equals, I'm going to factor a negative 1 out of everything. X squared plus 4x plus 3. Do you have to do it this way? No. You could do a times c, divide by a. You can do it that way. 0 equals negative 1. And now I need to factor x squared plus 4x plus 3. We're looking for two numbers that multiply to give us 3 and add to give us 4. So that's 3 times 1. And our lead coefficient is 1, so we know it's x plus 3 and x plus 1. If you need to see that in organized matter, 1 times 3 is 3, add to give you 4, 3 and 1, divide by 1, x plus 3, x plus 1. All right, set each factor equal to 0 and solve. This factor does not have an x in it, so I don't set it equal to 0. These do. So I have x plus 3 equals 0, x plus 1 equals 0. So we have x equals negative 3 and x equals negative 1. So that means we have two x-intercepts, negative 3, 0, and negative 1, 0. All right, let's go ahead and graph those. Negative 3, 0, negative 1, 0, and now we can make our parabola. So downward facing parabola. If you hold for a second, It'll clean it up. Here's your arrows because it goes on forever and ever, and that one's done. All right, let's move on to the very last one. So if you look at this one is in vertex form. So remember your vertex, super easy, it's HK. So you take the opposite of the H value, so that's 2, because the H value is actually 2, like this. This is the H value. Okay, so that's 2, comma, and then the K value, -6. Way easier, right? Y-intercept is always 0, comma something. X-intercept is always something, comma 0. All right, let's start with the y-intercept. So we're going to plug in 0 for x. So we're going to find f of 0. So that's 0 minus 2 squared minus 6. 0 minus 2 is -2. -2 squared is +4. Minus 6 is -2. So we have 0, -2. Remember, we got an axis of symmetry going through that red point. It's 2 away, so I'm going to go 2 away on the other side. So you should also have a point at 4, -2. Okay? Now I need my I need my x-intercepts. So remember, I got to set y equal to 0. So I'm going to set the equation equal to 0. X minus 2 quantity squared minus 6. All right, so once again, I got to solve this quadratic. I do not see an x squared and an x, so I can solve it by square rooting, okay? So I want to get rid of this square by square rooting, but I have to get rid of that -6 first. So I'm going to add 6 to both sides. I have 6 equals x minus 2 quantity squared, and now I can solve it by square rooting. So square root, plus or minus, x minus 2 is equal to plus or minus, and now root 6 is not a perfect square, and no perfect squares go into it. So if you look at our list of perfect squares, where are you? There it is. 6 falls right here, so the only possible one is 4, and 4 is not a factor of 6. So that just means it's not simplifiable. We're going to leave it as a plus or minus root 6. Okay? I still need to get x by itself, so I'm going to add 2 to both sides. And then I have x equals, remember you write this number first, so that's a 2, and then plus or minus root 6. So now I have my 2 x-intercepts. I have 2 plus root 6, and I have 2 minus root 6. And you can write them together like that. All right, now if you're saying, how do I graph that? Well, just graph your parabola going through your x-axis. It'll go through it for you. As long as yours is not absolutely wonky like mine. Let's see. Well, we're going to leave it because it's okay. So there's one and there's one-ish, mind you, because it's not perfect. All right, that's it. You can go ahead and get started on your homework.